Welcome to video lesson 8.2, and today we're going to look at dividing monomials. Go ahead and put today's date in the top right hand corner and write down our I can statement. Today's target is that I can divide monomials, raise monomials to the zero power, and manipulate negative powers to become positive powers. Now, the first thing we'll look at is our rules for multiplying monomials. And basically, they're the reversal of our multiplying. So where we multiply our coefficients, for dividing monomials, we're going to divide or reduce all coefficients and constants. And remember, that word reduce there means we want it in simplest form. So if you have a fraction like 2 over 4, reduce it to 1/2. And then we're going to subtract our exponents of like bases. Now, two quick rules to write down next are that all bases raised to the zero power simplify to 1. So that means anything and everything raised to the zero power will simplify to 1. And lastly, no negative exponents allowed. We know that from our examples of monomials. But if we do get negative powers, to make them positive, we change the location of its individual base. So it's just that one variable, or just that one base number in a fraction. So change the location of its base in a fraction. Alright, and you don't have to rewrite this rule. You already have it. It says all bases raised to the zero power simplify to 1. This just kind of proves why it does. Okay, so if you have, look over here at the right side with me, if you have 2 to the 4th power over 2 to the 4th power, you have 4 2's on top, 4 2's on the bottom, and they all cancel each other out, and 2 divided by 2 gives you 1. So over here, if you do 4 minus 4 gives you 2 to the 0 power, that would simplify down to just 1. So here's an example of our zero power. So if I have negative 3x to the 5th y over 8xy to the 7th to the 0 power. If you remember, whenever we have our power on the outside, when we have a monomial being raised to a power, it gets distributed. So everything in here gets to go to the 0 power. And because everything inside this parenthesis goes to 0 power, everything in the whole parentheses reduces down to just 1. Because the whole parentheses raised to the 0 power. So those are some of my favorite problems, because if you see a big parenthesis, and it's all raised to the 0 power, you know it's automatically just going to be 1. So here's another example for our 0 power. So we have t to the 3rd, s to the 0 over t. So let's see what we know. We know that s to the 0 power is going to give us 1. And we know if they're side by side, that means they're being timed. So that's t to the 3rd times 1 over t. Now t to the 3rd times 1 just makes 1 t to the 3rd, so we don't have to show that 1 anymore. So we just write t to the 3rd over t. And now that fraction bar means we're being divided, so we need to subtract our exponent. So 3 minus, there's 1 down here, so 3 minus 1 is t squared. Another way to do this problem is just go ahead and say s to 0 power cancels out, and so you're left with t to the 3rd over t, and you end up with the same answer. Alright, our next one is no negative exponents allowed. And once again, if you look right here, it shows 2 minus 5. Ooh, grab the white out instead of the highlighter. 2 minus 5 gives us a negative 3. What that means is I have 3/8 left on the bottom, and the top simplifies to 1. So if I have 8 to the negative 3rd power, and I put it over 1, we say he doesn't want to be on the top. He wants to be on the bottom. So let's see an example of this. So example, don't remember what number we're on, so this will be example 6. We have b to the negative third, c squared, over d to the negative fifth. So that fraction bar tells us we're dividing, but we look, I have b to the negative third. Do I have any other b's? Nope, so he's just by himself. So now we're going to simplify and say b to the negative third. We can't have a negative exponent. So if he's on the top part of the fraction, he doesn't want to be on the top. He wants to be on the bottom. So what I like to do is I like to go ahead and make my fraction bar and show them as I move it. So b to the negative third doesn't want to be on top. He wants to be on the bottom, so it becomes b to the positive third. Then we look at our c squared. His power is positive, so he wants to stay on the top. He wants to stay where he is. Then our last variable to look at is d. So I have d to the negative fifth. His power is negative. So he doesn't want to be on the bottom part of the fraction. He wants to change his location and go to the top. So d, and because he went to the top, is now to the positive fifth power. And that's our answer. We can't go any farther because they're all different variables. And remember, whenever you write out your variables, you always want them in alphabetical order. So it's c squared d to the fifth while you're changing their location. Alright, and this is example 7. We have negative 3a to the negative fourth, b to the 7th, over 21 a squared, b to the 7th, c to the negative 5th. Okay, so that fraction bar tells us we're dividing. So the first thing we want to do is see if we can divide or reduce our coefficients. So negative 3 divided by 21. 21 is on the bottom, so that means we're going to end up with a fraction. So negative 3 can go into, 3 can go into negative 3, negative 1 times. 3 can go into 21, 7 times. Then we look at our variables. So I have an a to the negative fourth and a squared. So when we're dividing, we subtract our variable's exponent. So negative 4 minus 2 gives us a to the negative sixth. And then b to the 7th divided by b to the 7th. So we know that 7 minus 7 is going to be 0, and 0 power means 1. And rather than writing that out, we can just say the b's cancel. If we have b to the 7th divided b to the 7th, they just cancel out. And I'm left with c to the negative 5th. He has nobody on top to go with, so we can just drop him down if he's right where he is. Alright, now we get to this last step and we say, is that answer good enough? Is it correct? And we see our negative power, so we know, no, it's not. So I'm just going to bring across my fraction bar. And my negative 1 over 7, I can't reduce that anymore. So my coefficients don't have anywhere to reduce because they don't have any powers. Now look at my first one. I have a to the negative 6 power. He doesn't want to be on the top. He wants to go to the bottom. So over here, I'm going to write a to the positive 6th on the bottom of the fraction. Same way, my c to the negative 5th didn't want to be on the bottom anymore because he has a negative power. He wants to go to the top. So it's now c to the positive 5th. And that's our final answer. And this concludes us for our 8.2 video. Hopefully you've reached your targets, and thank you very much.